Good afternoon. My name is Chris Holscher with Humana, and I'm going to talk about how we used Detector to solve some of our Db2 BIF compatibility issues. There's some legal stuff. We know why we're here. All right, let's talk about, jump right in, what problem brought us here today. We know that SQL is a concept. Every vendor that has SQL has a different flavor of SQL. There are standards that are written. Vendors can either exceed those standards, ignore some of those standards, and I'm sure that happens. Db2 being one of them. Oh, I should say that I had this presentation all written, and then Db2 had to go and change the name from capital D, capital B, to capital D, small b, so I had to rewrite this whole thing. But anyhow, starting with Db2 release 10, they changed the way some of their built-in functions work, notably char and varchar, when it relates to converting decimal or numeric values to character values. And the old way just won't work. A couple things that IBM did. They gave us a ZPerm that allows us to simulate version 9 behavior into version 10 and beyond. And they gave us some new functions, namely char9 and varchar9, to simulate what version 9 was doing. But how do we know what code to change? You could look at every piece of code you have, but that seems to be overkill. Luckily, IBM provided an IfKid, initially 366 and 376, that will show you what pieces of SQL, or at least the package name, violate these rules. For now, we can live with version 10 and version 11 with that ZPerm, but that ZPerm's not going to last forever. Okay, at this point, I'm going to talk about what we did at our site and are still doing. This is not to say this is the right solution or the wrong solution, merely this is our solution. The first thing we did was start the IfKid in our Db2 production environments. And those get written to SMF. We use CA's SMF manager to pull that data off on a nightly basis. The next thing we did was to go into Detector, into the collection profiles, and say we want to see the keys for every transaction in the distributed world. Why? Because we're going to use those distributed, for those distributed transactions, we're going to use those keys to match up with the IfKid information to try to find the hits that really need to be investigated. The third thing was we actually set up the detector collections to say we're going to capture keys. Now, something I found, and maybe however we got there, keys is not in any of the sample members. That's a parameter we had to find and add it ourselves. But I've circled it here. Keys, and I believe SQLT will also tell it to grab text for dynamic transactions, and then the keys parameter is important or else it won't capture them. Okay, so what we did each day is that we capture, in each subsystem, we capture the previous night's detector data. And it took us a while to find just the right parms to give us the minimum amount of data, but give us the right data. And I've included these parms here in what we do every night, about 2 o'clock in the morning. And you'll notice that my end time is 1 minute after midnight. It seems that if you put an end time of midnight, it won't pick up that interval. That's just the way Detector works. But by using these parms here, I was able to get back all the SQL data for the distributed dynamic data. Right, SQL, I'm sorry. Now, after I get all that, I do some match logic to match the IfKid records with the workstation ID, the username, program name, and everything else available to me against that same information in the detector output. By coming up with that, I have a pretty good list to start with of SQL text that may or may not be a problem. And why do I say may or may not? A couple reasons. There may be multiple hits in Detector for a IfKid hit with within the same time interval, user ID, program name, and I don't know which one. So at first, I take everything that matches, even if eventually I will discard it. Then I look manually through these threads, or I should say manually with a program I wrote, to look for the 4 characters CHAR. If I don't find those in the SQL, then it's not something that's going to affect me. And then I drop duplicate queries because there could be queries from different intervals within Detector that have the same SQL, but Detector doesn't know it's the same query, because once you're in a different interval, it could be different or the same, and Detector doesn't know. So I had to sort and then drop duplicates. Each week I accumulate the daily output. Luckily we have some information available to match the auth ID of the thread to that auth ID's manager. If the auth ID is not a real person but just an application ID, we have that same ability available. So we can send out an email to the manager saying, here are the transactions under your jurisdiction that need to be modified. And we email the weekly report. I don't want to bombard them every day because I just don't want them to delete the email as soon as they get it. And this is the format of what the email looks like. It provides the subsystem, the distributed server, the auth ID and the associated real person name, which kind of function call from the IfKid it is, either a 1 or a 2. When it happened, I can give them the interval, because that's what Detector provides, and then the SQL executed. I limit the SQL to maybe 1,000 characters. We have some SQL that is ungodly big. I mean, it generated 100 lines of Detector code at 254 characters a line. So we had some SQL that was over 25,000. I just don't think it's necessary to show that much. So this is the email that would go out. Now, what do the managers or the developers do with this information? When it comes to the BIF corrections, the easiest and safest thing to do is change every car to car 9 and every varchar to varchar 9. That way you've covered it all. It may not be necessary, but you know you're not going to have any problems afterwards. We did use this same process to identify timestamp errors, which is the third big one that we found, where they have to comply to a slightly different format of a timestamp using periods instead of colons on the time portion. Those were also identified by the IfKids, and this reporting does show that, but it's really a change to the timestamp, not to the code. Any warnings or suggestions? Yes. Detector releases prior to release 19 simply don't have the horsepower to do this 24/7. We have some of our subsystems, we're pumping out millions of SQL transactions an hour of dynamic, or so it seems, just lots. And release 18 just couldn't handle it, so we waited for 19. Oh, and this will come as a surprise to no one. Be current on all detector fixes. I found a fix as early as September that was affecting this process that I had to get applied. So Detector gives us many opportunities to apply fixes. Every product does. It's just Detector seems to be Detector. The third thing to be worried of, your detector sizes, your data store sizes will balloon because you're holding a lot more data than you used to. Ours at least went up 8-fold, possibly even larger. So that's something to plan for. You may have to resize them or get more, either to allow them to grow or get bigger DASDs so that even if they're defined to take secondary extents, that they've got room to put them in. There is a method that you have to employ for dynamic stuff. Timestamp format changes must be completed in Apple Compat 10. Once you go to Apple Compat 11, the old timestamps will generate a SQL code of -180. Now, both the old and the new work in Apple Compat 10. So really you want to make that change in Apple Compat 10. On the other hand, the built-in function changes for dynamic can't be done until Apple Compat 11 because the functions, the new functions, the varchar or the car9 and the varchar9 don't exist in Apple Compat 10. Now, for host-based static packages, a little bit different because you can bind the packages saying this is Apple Compat 10 or Apple Compat 11, but we really don't, in version 11, I don't have a way to bind a distributed package. So we have to follow this order for our distributed stuff. Now, I will say that when we first started this project 2 years ago, to get a proof of concept, I just did this for the host-based, be it the standard Db2 packages or any dynamics such as spoofy, unloads, fast unloads, anything that there wasn't a package for, but yet was identifiable. Since we were able to identify it by a job name in those cases, we didn't feel the need to supply the SQL text of the dynamic transaction, because they can go to a PDS member, a Panvolet member, they can find what's going on. But with dynamic, how can I say this? There is such a canyon between the mainframe folks and the distributed people who are writing this code. We didn't feel comfortable that saying this transaction took place in this interval by this user ID was enough to point them to the right information. It might have been, but we just couldn't ever get an answer to that. So I said, fine, I'll use some methodology of getting the actual SQL text of this dynamic transaction. Now, we looked at other products. We have a product called EasyDB2, which you can do manual queries on a given SQL transaction to get this information, but they did not appear to have a way to, in a batch mode, download this information and make it programmatically available to other data streams, such as the IfKids. So we went with Detector. It took me a while to find the right mix of parms to use to get just the data I needed. I still get more than I need, but it's programmatically viewable to see what you get rid of. And this is really an overview. If anybody wants more detailed information, some of it is in the notes associated with each slide. And you've got my email on the front page. I'll be more than happy to help anyone in detail if there are future questions. And here are some ponderables that There are no right or wrong answers. Is all this grabbing the SQL text really necessary? Like I said, we don't know. Maybe with the scant information we had from the IfKids, we could have given the distributed developers enough information. We decided to go the extra mile and get them the actual text so that they could grab it and run with it. How long will the BIF ZPerm override be available? I have it on good authority that version 12 has that BIF ZPerm. No promises have been made beyond version 12, which means probably we've got till 2023. I don't hope this doesn't take that long. How do we entice development cooperation? Well, we can't. Not until it gets to the point where we're going to go out of service on a supported release of DB2 that has the BIF ZPerm. When we get to the point where we can't use and override ZPerm, that's the only point when we actually can force the developers to do this. As many of our developers are outsourced, they're outsourced for a specific purpose, to write new code, to fix bugs. We've run into this before where we said, hey, let's come up with a standard across the company policy of purging obsolete data. Their response is, our contract doesn't cover that. It's the same thing with this. Their contract doesn't cover writing DB2 manifested changes in the code. If there's no bug, that's not their job to, at least in their mind, it's not their job to fix it, because it's not broken from any standard of code defect. So we're still working on that. We've got a couple teams that are willing to jump in, but we've got other teams that aren't as willing. And did we do test or production? Initially, we're just doing production. The thought being, as they change things in production, they'll change the same programs in test because they got to test them. Now, we all know that no one ever moves something to production without testing, but we're going to do our best to turn this on in test later on a more limited basis, because that'll send our data stores out the roof. But for right now, we started in production, and we'll retrograde to test if that becomes necessary.